Hello everyone, it's Heider here. Good to be back on the channel on my next video. I think most people I spoke to were pretty anxious to see what's going to come up. So really thank you for the support and the comments and all the wonderful things that you've been sending. Just before we start the video, I wanted to kind of really sort the logistics out. I've worked on well, I've not done it before, but I've done a Patreon page for me based on some recommendations. The Patreon page is patreon.com/Heider Sati. The link below the description if you like to read it. This is basically I've created a few levels. You don't have to, but if you like to support me and contribute to what I do, that'd be great. Until this point, I've not had any member or anyone paying anything to my work. The issue I have right now is because this is all free work. I've got a family to feed and kids and to grow and all that kind of stuff. Most of the time, including the last 6 weeks, I actually get pulled out of whatever I'm enjoying this work here and move on to a paid work to make money. So even though some might think of me as a retired, but I do these things all the time, obviously, so running into situations. But anyway, the other page I created is on Facebook, which is a facebook.com/Heider Kronos. I could not find the Kronos project, but the Heider Kronos is actually called the Kronos project. And this is basically for anyone to come and find out what's happening, kind of a short update to say things like, I could not post today's video because I had a corruption in the hard drive. Something like that. It's just a quick status update. There's no point for me posting videos on YouTube every 5 seconds about, 1 minute short videos to say what's happening. It's just time consuming and I really have not time for it anyway. So, yeah, so this is basically, in essence, and most people who doesn't know this channel is youtube.com/Heider Sati. So again, that's just sorting the logistics out. So thank you very much for your time and support, and let's get started on this and see how it goes. Just gonna power up this instrument. I hope you guys can see me on the on this camera. Hello. Okay. Right, so powering up. Believe it or not, I had a problem with the the bloody keyboard. When the cheap keyboard I actually was using down here earlier on, what happens is because the keyboard does not get the reset signal when you press power up and you get that little 3 lights blinking. When I press F10 sometimes it doesn't take me to the other BIOS menu or F2, so as a result I have to reboot the system a few times halfway through the booting, and that sometimes cause corruption. But that's not the issue. The issue was something else. I think it's a bug in the system to do with the bprintk module, but that's fine, doesn't matter. Yeah, so anyway, let's just start. Right, so most people, upon my last video, what we talked about on Kronos Hack 4 is things where we fixed the OMAP interface powering up and stuff. I think I've done a lot since then. Things I can't talk about really, but the ones I can talk about, because this video is mostly about the OS stuff or reworking on the operating system itself, not anything else to breach copyrights. So in essence, I managed to sort a lot of things out. Take for example, let's power up the system and see how it goes. So at the moment, what you're looking at now on this system is my operating system. It's not the Kronos one. So if if I just go into the start installing, ins mode, user, real-time modules, RTAI HAL, and shared, and FIFOs, and DBG, SAM. So now these 4 elements, which is RTAI HAL, RTAI shared, RTAI FIFOs, RTAI SEM, and the NDBG as well, are part of the, well, forget the NDBG here, but just these RTAI runtime application interface. These are the built-in, these are open source items that comes with the system, or can be compiled with the system, and they are okay to be modified. So RTAI is basically the real-time application interface, which is part of what we're going to talk about today in this video, and to explain what is going on with this, and we'll take it soon from there. So now RTAI is up and running, and if I then I'm going to do a ins mode, it's the Korg mode STG. Yeah, move that there, that's fine. That's not this one. STGE. I know I'll move this here, hold on. Oh yeah, ins mode, Korg. There we go, sorry, yeah. STG enabler. So that powers on the STG enabler. Not really, touching that yet or doing anything on it right now. And then you got the OMAP NK's video module that powers up the I/O to talk to the Korg device on 944 and 1005, and then the video module. So now we have the video buffer all connected to the system inside, and we're going to do STG GMP. That's all done. Right, so up till, and then also we got the USB, let's do it now. So module, USB media accessory, and then the Korg audio driver. So now, LS mode, you can see on the modules here, I don't know, you should be able to see it. I mean, based on some comments I had in the past, they asked me to increase the fonts, and I did. So that's slightly bigger font size, but that's the minimum I can work with. So I hope that makes sense that you can guys see it. So now you can see the modules loaded on the system. Up till this point, everything is hunky-dory. There's nothing wrong with this whatsoever. The other bit we were working on in the previous video is loading up the OA.ko, and that was failing to load. I fixed the problem with the probing and the loads of stuff with it as well. One thing I came across is also on this, just before I carry on, is a function called CD-ROM find device. And that function, OA will not start until you actually load that function up. That function, just in essence, basically, it will load the device list, iterate through devices, and give you the device that you're looking for. So say, for example, I'm looking for device 123. The system will loop through all the devices. Will say, is this ABC? No. Is this 5, 6, 7? No. Is it 123? Yes. Here we go. That's your device. Take it and go. To Korg, if you are reading this, you got a bug in that find device module. If what you're doing, you're iterating through devices, and if you find the device, you return it nicely. But if you don't find the device, you return the last device you searched. So let's say you have 5 devices in the list, and you're looking for device 1, 2, 3, and that list contains none of the 1 to 3. It will just go 1, 2, 3, 4, 5, and then 5, because this 5 is not the same one. It will return number 5. Now that is I would say, dangerous thing, causes corruption sometimes, because you could be returning the wrong device and then the system write into it and then cause all sorts of problems. So if you are listening, hopefully have a look at this CD-ROM find device function, and please fix it. It's a bug. I already fixed it on mine anyway, just so you know. Yeah, so that's one thing. So the other bit now, we're going to power up the OA.ko. So ins mode, Korg mod OA. So now this is what, call it the bread and butter of the Kronos system. So that here will try to power up, but as you can see it failed to power up now, and I'll explain that in a second. Yeah, so this is basically the OA system is what power up the system, and everything talks to it, and that guy will talk to the other devices. It's yeah, let's just explain what's happening with it now. Remember what I just said about the CD-ROM find device function. That function is not provided with the OS. It does not come with the OS, but OA will not start unless that function is found. That function does not exist in any of the Korg implementation or drivers whatsoever. It's built into the system. What that means is, in English, is even though Korg has sent you the source code files for the operating system, what they haven't done is included that function in the source files, which is pretty much against the license, the Linux licensing system. So, and to be honest, I don't really care. I don't think they care about that much anyways. It's open source anyway. You know, you can do what you like. But you know, to keep things tidy and nice, they should have really included that CD-ROM find function. And to be honest with you, I might have another video on my what's it called, Patreon channel, to include how to reconstruct that CD-ROM find device function. If you like, guys, to watch it, I might include it. Just ask. It's not a problem. So yeah, this is one part. So why they have done it this way is to, I think, pretty much to lock you down, to say, even if you remove that OA.ko from this system to another installation, it will not work because it needs that function. And this is one of the things that either it's a protection or some negligence or something gone wrong, and they forgot about it. But anyway, the CD-ROM function now is back into the device. It's there, it's working, it's happily ever after. Now, into the second part of OA, why wouldn't it start? Is because it's trying to find something called orig mem size. Original mem size also is another function, is a variable. The system would read to see what's the memory on the system, and that's not included in Linux. So again, I reconstructed this now, so I'm just going to install it for you just to show you that in slow motion. So insmod, Heider, and then info. So now I've got that installed, as you can see it, and now you're going to install the OA.ko file, and voila, it's now thinking about it. It's going to go do stuff, and then it should come back and say, yes, I'm now starting fine. I've never had this, it shouldn't take that long. What's going on? Yeah, there we go, sorry. It took longer than expected. It's mostly because I think the symbol table is quite large on my installation, because I'm actually debugging the system. So rather than searching the file system, which contains about 1,000 elements, mine contains about 100,000 elements. So to search that up and come up with this, it's why this is taking time. So yeah, now powering up, system is finding itself, and you'll see also in a minute some debugging information I put on the operating system to dump what this guy is doing. So you can see here, for example, when you power up the OA.ko module, it really should send the VM allocation. Where is it running? So the physical status 19,000 or 41,000, whatever it is, and then the memory, blah blah. And then look at this. So you got these lines in here, and this will talk about the RTF. And so RTF is creating a device called RTF 0, 1, 2, 3, 4. So 0, 1, 3, 4, 5, 7. And then also, that's something else I've actually picked up as well. It's registering a device called STG Direct and starting the synth now. So all that stuff in here, apart from starting the synth now, this is something I actually wrote to the operating system, not to the module itself. So the operating system, whenever you're trying to register a new device, it will say, yes, someone's trying to register the device, here's what it is. So that tells me, you know, who's talking about what, and without even touching anything to do with Korg or their stuff. It's what you ask for when you do an open source system, isn't it? So, you know, you go on open source and I can tell the open source to log stuff for me and do the wonderful thing. So there you go. Now what happens is, you got, why am I reading that stuff? You'll see in a second. So you got RTF0 is creating a queue of 400 hex and byte, which is, you know, 1024 or 1K. RTF1, same thing. That's I'll explain that in a second. And then you got the RTF3 and 4, and then 5 and 7. So they're not doing 2, they're just 0, 1, 3, 4, 5, 7. These are the RTF devices. Now, so up till this point, now we have the backbone or the backend system of the OA is talking to the USB. The USB is talking nicely. The red bit in here, I don't know if you can see that. Can you see the red? The red slider is like halfway through here. So I hope you guys can see it. So the slider is there halfway through. The other half is where you start the application up. And this is where the EVA system comes in. EVA comes in, will pick things up, load the OS from the file system of the hard drive, and then push it slowly, slug into the what they call the Shark interface or the OMAP. So push that in, and then we'll say, okay, power up now, and then thank you very much. So here, if I go into Korg EVA and then run the EVA system, this is, by the way, the decrypted file system. You probably won't find this on your system anyway. Here's what's going to happen. So if I do that, okay, now what's happening is it's trying to wake up, it's trying to do stuff, but it's I can't do this. So yeah, it's basically to do with the frame buffer device can't be opened, segmentation fault, blah blah blah. Part of this because I'm actually running on a different OS with different users and different permissions, different privileges. So if I just go into the frame buffer and say, for example, the chmod 666, I can do 664, but 666 is fine, so /dev fb1. So now I've added permissions and said, actually, give everyone read-write access to that frame buffer 1 device. And now I run this EVA again and see what happens. Right, now look at this. So now a different message. And this guy says now change to initializing user interface instead. And the light, the hard drive light blinked once. Now, that is a thing where we're stopping at. Notice direct equals -1. And that's also another problem to do with it cannot read the messaging device. So if I look into dev/dm stuff, nothing. So if I make node, I think, let me just do this now first to see if it's going to work or not. So make node dev/dmsg. So this is how you make the nodes. You're creating a new device inside the dev. And then I'm going to let the OA pick up from that point. So dmsg0, I'm going to do character device 150 and then 152 and then 0, and then dmsg1 is 1, and then dmsg2 is 2. And I'm going to run this EVA again. No, so we got the dmsg is incorrect, so let's just redo the dmsg 012 to 154 instead. Let's just dmsg, let's do 154, and then 1 into 1, and then map 2 into 2. And now let's do EVA. Like, oh yeah, bugger. Sorry, it was the right thing. Hold on. I forgot one point. So I created a device because I'm root. The system will not be able to see it because it's not using root user, which is fine. So let's just do chmod. I might have to recreate it as 152 anyway. So the chmod 666/dev dmsg stuff EVA. Yeah, so let's just do this now. rm -f dev DMSG star, and let's just recreate them as 152. So 1, 2, and 0. No, so yep, and the chmod 666 dev DMSG 0. So now we've recreated them. There we go. Okay, so now what I've just done is creating the nodes for the messaging device, and the messaging device has now been taken care of by the OA.ko. And what's happening right now is it's opening the devices nicely. In the past, you can see here the kg, so from kg12 to kg13 and direct -1. What that means is RTF 0 is 12, RTF 1 is 13. These are the handle numbers. And directing is -1 because I can't open direct. Now we've done this stuff, and now direct can be opened as 15. So 13, 14, 15 is the handles that the system needs, the base handle needs to talk vital in order for it to actually start working. So what's happening right now is you can see the progress bar increase by 3, by another, I would say 30%. But that's a fake increase, because every time I run the system, it'll keep pushing the red thing up without even thinking. So that's one of the other bugs that they have. The increased progress bar will increase it without thinking, oh, where am I at the moment? Just going to push it. So you can just go so much, but that doesn't care. That doesn't matter. It's irrelevant. So what's happening right now is the system kind of in a frozen state. It cannot really power up. There's something missing. It's just EVA is trying to talk to OA.ko, and it can talk to the frame buffer, because as you can see, the progress is increasing. It can do stuff, but there's something missing in order for it to actually go through this. And what that means is, after looking into the system and then spending about a couple of days on this, maybe 3 days, it's writing something somewhere and trying to read something from somewhere else, and that something from somewhere else isn't coming up. And that's the topic for today's conversation. So what is real time? What is RTAI? So talking into RTAI is the real-time application interface, and what that means is, in other words, you hear a lot in the Linux world talking about, oh, we're going to use RTAI this, RTAI that. What exactly is RTAI, and how does it work? And a lot of people you ask, they probably don't know. It's a mystery, and they may not have the right information. So RTAI basically is real-time application interface. And what that means is it would create, especially talking about in particular the FIFOs, or the first in first out, it will create a set of queue buffers, and these queue buffers will facilitate you talking from your user space module, which is the most untrusted thing in Linux or any operating system, to allow it to talk directly to a device or something on the kernel side via queues. So, for example, you can say to something like, I want to send message 1 and then message 2 and then message 3, and the kernel will queue these up in a buffer somewhere. And then when someone wakes up in the kernel, it will say, oh, there's someone trying to talk to me. So pick up, yeah, we got someone reading message 1. There we go. Then when you read it again, reading message 2, and so on. It's an interesting thing. It's an interesting way to do things. I don't want to go too technical on this, but if you guys like me to explain it further and do examples on it, I'm happy to do that now. And I'll show you I've actually wrote some modules and things to test the RTFs and stuff, but just to let you know on all this, an RTF is real-time application interface. As I said, what happens in reality, it will create a set of RTF devices on /dev. So You got RTF 0, 1, 2, 3, 4, and so on. To be honest with you, I can take you through that now, but you can see I just wanted to stop you there just to show you what's happening on that side. So, in essence, the system will not power up because it's actually waiting for something. It just, you know, something is kind of missing. The OA isn't sending something back. Now, I'm just going to, without wasting too much time on this, if I go back and take you to the RTF and what can RTF does or do, I can show you that. Let's do this. I'm just gonna yeah, let's do that. Why not? So if I go into the system and let's just look into my code. So I've written some stuff on RTI. So I wrote some modules on some devices and all the rest of it, just to see how things are going to go. I think, to be honest, for safety, I'm just going to uninstall the Kronos one first, and then yeah, let's just do it this way. I think it's better. So deregistering everything, reboot. Yeah, I'd rather do it this way. So I just want to show you what exactly is happening. It will all make sense in a minute, but RTAI is call it like an intermediary device. What happens is you open up in real time, in user space, you open up a device to say, I want to write to it. You write, for example, hello world, and then someone either from back to the user space can read it again, or someone from the module space, which is the most trusted one on Linux, will actually read it instead. So I just wanted to, if I walk you through this, let's just let me just do that instead. Yeah. All right. Just wanted to explain what's happening. Really, just makes more sense. So, what is RTAI? You've got the kernel space. Sorry, kernel. Yeah, and you've got your user space. Okay. Now, you got your USB device. You got frame buffer device or the VGA device, HDMI, whatever, Bluetooth. All these are devices, etc., etc. Now, when you try to run something on Linux or even Windows, actually, you cannot run your USB device driver in the user space. It's non-trusted. It doesn't work. It'll cause so many problems, and nobody will allow it to run because there's so much security go on between them. What happens is the kernel will come and say, I'm going to install a module, and that will talk to the USB in and out, and I'm going to do mod 2, and that will do the same thing in and out here. So basically you got the modules will talk to USB and all these devices. And then either for anyone from the OS to talk to these modules, they're going to have to find a way to talk from user space to this guy here. Now there are a few ways to do, and usually the standard or general way is to open up a device driver, and we'll register, for example, this guy will go and create /dev/USB, say core 1 or 0, whatever it is. And then this guy will say, I want to open that device. It will open it, and they will push something to it and then read something back from it and that sort of thing. But this way, yes, it works on Linux, and this is the standard way on Linux, but it's not the ideal way. I wouldn't say the ideal. It's not. Let's just say it's too advanced or too technical for someone who doesn't really care about how these things talk to each other. You just want to say, for example, I want to have a device. I want to say, send hello world to the USB device straight away. I don't want to go through this, talk to the device, set up URBs, set up frame buffers, and you know, there's a lot of things, there's a lot of cooking involved in doing this way, but rather this user space want to talk to this device in a different way. So rather than doing this twisted way, also the other disadvantage of using this way is if this guy sends hello world to this device and this guy wants to read what this device is, and sorry, let's say you send hello world to USB via this way, and then the USB say, okay, here's my response to hello world, it'll say hello back. So by the time it sends this here, and then this guy reads it back, this guy gets confused, says, oh, is this something I sent already, or is this a message I am actually reading, or sending something back? So it does require a lot of synchronization and queuing and all the rest of it, which is not really ideal. So the way they've done stuff, rather than doing it this way, what they've started to do, or what they've done instead, they have something called the RTAI module. So RTAI is another module installed on the system, and when you install it, it will give something like dev/RTF0, RTF1 until RTF, say 39 or whatever it is, right? So it will give all these real-time FIFO or queues. And what that means is this guy will say, for example, I know what to do. I'm going to send all my stuff to RTF0, so we'll do this, and I'm going to read all my stuff. So I'm going to send something. So this is the output, and this is the input. Okay. So what happens is, this device will start doing thing, for example, instead. So asynchronously, we'll say hello in one message, and then how are you doing in the second message, and then I need please start in third message. So this guy, you know, picks it up. This RTAI will interface with the other guys in here. So RTAI can read it from the kernel space module, or you can read it also from the user space module. So the kernel space will read it and say, yes, thank you very much, hello, and it'll say hello back, but it will not say hello back on the same RTF0. It will say hello back on RTF1. It's because you're asking it to. So RTAI will say, here we go. Thank you very much. I am going to talk to whatever, you know, for example, USB device, and I'm going to talk to, so this guy will do this, and this will do that. So what that means is, this out hello will go to RTAI, RTAI will go and send it to USB, comes back into RTAI, and then yes, hello, and it'll go back to RTF1. So now what happens is, RTF0 will be always used to be sending stuff out, which is what we saw in the Kronos. So this guy will saying hello, greeting and all that stuff, but somewhere here they have to send something back to it to say yes, okay, fine. So in essence, 3 messages being sent, and this guy can read 3 messages back, and so on. So I hope that gives you information or the understanding of what RTAI is. So I can create a queue. You know, I can say, for example, the queue size is 4,000 or 400, you know, hex or 1K in size, and I can send messages, so much messages in here, and all these things gets queued inside the RTAI module, and RTAI will know where to go because you got someone says I'm interested in these messages. For example, in our case, it's going to be the OA KO file. OA will read from RTF0 and will respond accordingly. So what happens in this case, for example, let's say increase the tempo of the instrument. So it will send it to RTF0, go to this OA, and the OA, as I said, backend. We got this powered up. The RTAI will, sorry, the OA will talk to USB, send it to the Shark or the OMAP interface to increase the tempo. You got more blinking light quickly, and they'll come back to RTF1 saying, yes, I've done it, thank you very much. And this guy, EVA, is where your screens will come and say, yeah, that's fine, he increased the tempo, and now we have a nicely synchronized system, well, asynchronously. So I hope that explains what RTAI does. And to look into this further, We're going to now look at this in more detail, and then eventually we'll get this whole thing to work, you know, once and for all. So let's log into the system. Sorry, I kind of too much. But I just wanted to take you through the RTAI itself. So now I'm into RTAI, and what I'm going to do is, before I start, let's show you the devices on the system. So at the moment, right now, the devices on the system are as follows. All that stuff is here: TTY, STB, loop 0, all these things as a standard Linux devices. If I need to install RTAI, SVN, user, real-time, modules, RTAI. If I start installing the FIFOs, which is what I'm interested in, RTAI FIFOs, it will not work because FIFOs requires, you know, previously installed modules. And so to begin with, you need to install the HAL, which is the hardware abstraction layer. Yeah. So that's now installed. So the RTAI now knows the hardware and can talk to it nicely. And then you install the scheduler. You have to install the scheduler. This is part of the FIFOs. And then the FIFOs. So now the FIFOs are installed. If I read the USB devices or read the device list again, you can see the difference on top, on the bottom. So you've got now the RTFs all created by the RTAI. So RTF 0, RTF 1, and so on, they're all created. They're ready for you to send messages and receive messages, etc. And then it's looking for a nice happy ending. So that's all done. That's all, you know, set up. And all I have to do is go and read and talk to it. So if I, just to give you a really simple example, if I echo hello to one of them, so dev /RTF 0, right? So now, if you look at this, that message is not something that comes with the RTAI. This is something actually created on top of the RTAI module, just to log what RTAI is actually talking about. And that's an interesting one. This is part of the beauty of the open source system. I've kind of, we'll call it hacked, but inside the RTF create function, or whenever someone trying to abuse or use the RTF device, I want to see what's happening in there. So if the Korg or the OA or the AVA trying to talk to it, I want to know. I will actually pick this up and then say, yes, I can log this whole thing up. In fact, I can pretty much log all the IO to say EVA is talking, saying hello world, and OA is reading hello world, and OA is responding by saying yes hello world back, and I can log all that stuff and then, you know, dump it all for having the error. So now, if I echo or cat /dev /RTF excuse me, yeah, /RTF 0, right? Now what's happening is, you can see that I now have read that stuff out. So you can see I've wrote into it, and now I've actually, you know, read something from it. So I'm gonna do it again. So echo and then cat, and then I've got the data out. So if I go back into my own modules and then show you exactly what's happening, I can actually do a nice logic. I can say, if I'm going to send hello, then please put RTF1, fill it up with hello back, that sort of thing. So if I install module, and then I would do RT, which one does it do the echo bit? Okay. So now I've installed my own module to say here. So I now use these things to send something out. And now I'm going to echo, do this thing again. So I'm going to echo hello into RTF 0. And now you can see here, when I do the echo, because I've actually got a handler there, my handler, my the one I just installed now, will say, yes, someone has been sending me a message. So the minute I fire up that message, the handler wakes up and pick it up and says, oh, someone's trying to talk to me. And then we'll say, greeting received, replying back. So you can see this here. This is my code responding and saying, yes, someone's sending me something. Here it is. And if I echo, actually I'm replying on RTF1 as we said on the blackboard just now. So if I echo cat /dev /RTF1, and as you can see, it will say hello, okay. You see that? And so this is the beauty of RTAI. So what happens in that case is, I have managed just now to send information from the user space module, which is someone typing hack stuff or whatever it is, and that went deep into the core of the system, which is where the module space run. And that's the module space is where everything talks to each other in a secure and kind of a trusted way, not secure, it's a trusted way. So this guy will talk to USBs, frame buffers, all that kind of stuff. And that's one of the things I actually can do to kind of tap into things that no one else can tap into. So I can run and then go and say, go and fetch this and come back, and it'll say, yes, here you go. That's the stuff you're asking for. Anyway, long story short, you now can see the system. So if I send something out, I expect it to send something back in again, and I can change the different devices and all the rest of it. So if I uninstall now my module, so rmmod, and I do rt echo, and it's gone. So if I do the same thing again, so if I echo into the RTF device, it's trying to create it, but there's nothing listening on it. And if I, cat RTF1, nothing comes up. So you can see the difference. With my module, if I write into it, it will say, yes, someone is writing, I'm writing back. Without the listener, nothing happens. Yeah, and that's something, you needed to kind of see live. So now we haven't got anything listening on this now, and if I'm just going to, let's just start the whole thing. I've already, rather than typing every command in to start part of the Kronos, I'm going to type the stuff in, power everything up in one go. I've got a script in there, which is the basic what we just did, the previous, restart of the system. So now everything will start up now, and we should get a nicely starting up system. EVA will be in the same position though, and this is where things are going to get slightly interesting. And by the way, if Korg is seeing this, for the life of me, I don't understand why have you done a loop instead of handler. And in English, what that means is what you've done, or how RTAI works. You can tell RTAI to go and say, like I just did, if anyone hits that RTF, the handler wakes up instantly, fire the code across and comes back and everything. And if you don't fire anything to it, it will just sit there waiting, doing nothing, and they will not yell at any time of the CPU. That's the standard way. But to Korg, if listening to this, what you did, you went into a loop, you created a thread, that thread will loop stuff down, and it will, every time it says, do I have anything on RTF1? No, go back and sleep. Do I have anything on it? Go back and sleep. And it will keep looping in that. That does take CPU time, not a lot, because you have that kind of little sleep, the nano sleep in the code there somewhere. But to be honest, it's not ideal. In essence, if you take this code and run it on a, I'd say faster CPU. I mean, let's just explain this further. Intel CPUs can be forgiving when you run codes like that, because it doesn't heat up. That sleep will kind of take things nicely. But if you take that code on an OMAP interface and run it directly there, that CPU will not forgive you because you're doing it this way. It will generate some lockups, some freezes, some things that will not go through. And I think my understanding is of the PA series, or the PA4 or PA5, they probably are running on the OMAP. I haven't even looked into this. I don't know what they are, but I know there's no Intel there. And if I'm guessing correctly, if you run that code, I suspect these things do lock up sometimes, and I have not because I've not used this much anyway. I don't know, but just guess. If you are in this, if you're card listening running into this problem, then this is why you're having this problem, because you have that kind of loop in there, and you should really consider using handlers instead. So hopefully free advice. Anyway, so now we powered up the OA.ko, everything is running, the progress bar is halfway through. Now we're just gonna call EVA, and we are running into EVA, and it will not run, obviously. It will open up the devices and it'll wait there forever. So what happened just now, just going back into the example, this guy went in and sent something like hello world onto RTF0. And what's it doing at the moment? It says, I'm just gonna wait until someone comes back to me and then save me by sending something back on RTF1 that says, yes, I'm alive. So I'm going to do now, as you can see, my shell is locked, and I need the shell back. So if I'm just gonna, I can Control C and break into the shell, or I'm actually gonna use a laptop just to show you what's happening. So now here's my laptop. Just let me log in first to it. So just logging onto the Kronos. Okay, so now I'm logged into the Kronos here. I'm just going to give you my back, it's difficult to hold this like that. Anyway, so I hope you can see that side of the screen. So if I go into, what am I doing? Yeah, Kernel. I probably need my glasses, I'm not really seeing much. Anyway. Yeah, sorry, it's the RTAI. Yes, okay. So, remember what we said about this guy waiting for us to receive something. So if I echo, I called it the EVA key onto /dev/RTF1. So now all I'm going to say is I'm sending back something to RTF1 to say, here is the key, or here's the data back for you. So if once I've done that, hold on. There's no echo, it's cat. Yeah, if I do that now, there. So what I just did, I fired up the thing that says, here we go, I'm alive. And look what happens, the hard drive life is starting to power up, initializing, loading the preload system. Now all this is happening because I just said to it, here is the, yes, I'm alive. And RTF1 now has the data that says, yes, I'm now going to power up because I now, someone replied back to me, the OA is there, and I'm going to carry on. So now you can see the progress bar is actually increasing, and the hard drive light is actually starting. What that does is now it's loading up the stuff from the hard drive system, talking to RTFs 3 and 4, 7 and 1, and then 0, and then sending it all the way to the OMAP inside this screen in here, and that's now going to start up. So I think we're done with the laptop, but you can see I use the laptop now to tell the system that yes, it's all. Don't worry, it's all there. You're safe. Here you go, power up, and it went through it. So you can see now, the system is starting up. The hard drive light is actually powered up. And let's just wait for it and see what happens. I hope this camera is recording, so that's good. And hopefully that you can see the red increasing, hopefully. You should be able to, yeah. By the way, the reason why startup takes a slightly longer time is because I have so many symbols to debug the system. And as I said earlier on, every time it's trying to look up something, it will go through 100,000 elements trying to find which one it is, and that's because of the debugging. So once I'm done with this, I can guarantee I'll speed it up a lot more than what it is now. So now we're on to, so the red one is increased to the A. You can see it's actually increasing, the hard drive lights is flashing and that sort of thing. Yes, now the I. So I hate that startup for taking so long. It's just anyway. So now look, we're nearly finished the starting up, and I'll let you see. So there you go. So dump song bank 0, CNET config, selected interface, blah blah blah, ether 0, and that's the proper way of starting up the Kronos. And there we go. Right now, as you can see, the system has now started. But and that's pretty much the closest to a call it an Independence Day. Anyway, the problem, what you can see now, is nothing. It's dead. There's no lights, nothing happening. Whatever you press, you know, it's a dead system. It's a dead system because it's got no ghost. It's like someone, you can see a flesh, but there's no soul in it, or no ghost, or no spirit. In the Linux world, or in the language world, it's not demonized. So what that means is, yes, it's got the chassis all there, all the muscles, those skeletons, all the bone structure is there, but the muscles aren't running because there's no one telling it to. And I think that is where I'm going to end this video today. So my next video will be about powering this whole thing up and doing a lot more stuff than we just saw. So I kind of hope that this video was, you know, intuitive and show you exactly what happened. And again, to Korg, if you are listening, I have not touched your code. I have only did stuff to the operating system modules that you sent us. That includes the RTAI and the application interface and the operating system file. So I did not touch your code. I only looked and worked on the operating system open source files that you sent us. So thank you for your time, and have a wonderful day. Well, I'm sure I'll see you on the next video, and it's gonna get more exciting, I promise you, because now once I'm done with this whole thing, demonizing this whole thing, we will jump into stuff about the enhancement stuff, whereas things like, you know, pressing a button does what, that sort of thing. And I don't know, let's see how it goes, and wishing you a nice day. So thank you for watching. See you later.